Okay, it's working, hopefully. I haven't made a video for so long. It's been like a year or something. As I'm creating this web page for you guys, it's about linear table. Actually, there are like two topics. One is the linear table, the other one is the exponential table. We're heading into that chapter, but it is a very useful skill, as in, sometimes you'll be given a table of value and you want to tell if it's a linear function versus is an exponential function or not. So as I'm trying to create this web page, I realize, putting all these things on this web page is not going to be all that useful. It's going to take me a long time, so I've decided let's just do a video about it. So after this lesson, of course, I will talk about it in class as well. After this lesson, you should be able to check if a table of values is a linear function. Be able to find the y-intercept and slope just using the table. And finally, if it is a linear function, then you should be able to give me the equation. So the problem being with a table of value is that there are so many different ways they can ask this type of question, so you just need to be very familiar with what you're doing. Okay, so that's what we are heading into. As you can see, there's really nothing on this page just yet. When it's done, hopefully I'll put the video over here and I'll put the exercise over here. Okay, so that's what I'm planning to do. Let's get out of this. Okay, so first of all, we want to check if a table is linear or not, which is really not that difficult. For example, I have a table of value. This table I basically use decimals. I generate a table of value, and I want to check if it's linear or not. It's normally not really that bad. What you will have to do is, you see those arrows over here? You're going to put them right next to each other. Of course, you may not have the arrow all the time, but in your mind you should be able to check. So what you're trying to do is you're checking the value for the x. You want to see if it's going up by a constant. So from 0 going up to 1, from 1 going up to 2, going up to 3, going up to 4, going up to 5. So the idea of this is you want to check if the change of value for the x is a constant. So if it's a constant, then you're good to go, at least on the left hand side. So I'm just going to quickly write down, yes, this is always adding 1 to it. Okay, it's always adding 1 to it. And this is not done, this is just half of it. You have to check the other side. So I'm going to grab this arrow and I'm going to grab that. You're going to check if it's going up by a constant again. Basically means it's going up or going down at the same rate. So in this scenario, I can see that from 3 to 7 is going up by 4. And you want this is going to preserve, it's going to stay. So 7 to 11, is it going up by 4? Yes. 11 to 15, 4. 15 to 19 is going up by 4. And 19 to 23 is also going up by 4. So there you go. So if you look at the table on the left and the right, they are both going up by a constant. Then it is going to be a linear equation or linear function over there. Now, something I want to talk about over here, which is this part. Okay, it's not necessarily always going up by 1. Okay, so you have to be mindful about it. Sometimes it's not going up by 1. Okay, so that's the easiest way to check it. Check the left and the right. If they're both going up by a constant, then you're done. You have a linear equation. So if it's not, then the rest of this video, the rest of this exercise is no use, because it's all tied to the idea that you actually have a linear table to work with. And for the exponential table, I'll talk about another method, how to deal with that. So let's move on. So the other thing that they will ask you to do, normally if the table is linear, then there are a couple of things they can ask you. So slope and y-intercept, pretty much like the big things out there. They'll say, well, can you give me the slope? Can you give me the y-intercept? So if you're in my class this year, very likely that you've done a whole bunch of things about slope. Just to remind you, let's double check if this is actually a linear equation or not. So it's going up by 1, going up by 1, going up by 1. All of this is adding 1 to it. So yes, it's working. So how about this? 0 to 5 is plus 5, 5 to 10 plus 5. So all of these actually adding 5 on the right hand side. So I do have the constants. On the left is plus 1, on the right is plus 5. Therefore, yes, it is a linear table. So we don't really have to worry about it. So when we have that scenario, then we can ask ourselves, what is the slope? What is the slope for this? So the slope, there are a couple of ways to do it. I would normally just pick the first 2 entries of this. You can pick anything you like. You can pick this and that one. So I have 2 points. Hopefully my handwriting is a little bit better. You have a 1, 0. And you have a 2, 5. Then you should be able to find the slope with that 2 point. 5 minus, so m is equal to 5 minus 0 over 2 minus 1, which is 5 over 1, so the answer is 5. Okay, so the slope is totally doable. You just need the slope equation for it. So slope is 5. Okay, so that's how we get the slope. Let's fix this a little bit. So slope is 5. The y-intercept. The y-intercept can be a little bit more tricky if you are looking at the table of value. So remember that the y-intercept happens when the x is equal to 0. So you're looking over here, we do not have it, they didn't give us that. So you have to be careful how to go about doing this. In your mind, you'll be saying like, oh well, I'm looking for another entry that's right over here. Okay, it is before that one. So how can we go about that? Now, as we were checking, the slope is going up. We have to go the reverse order. So it's going back to 5, going back to 4, 3, 2, 1. So if we go up one more step, then we'll have the 0. The 0 is going to be one more step. That 0 is looking really ugly. But you can see the picture. We are going to go back 1 entry every single time. So alternatively, not alternatively, like on the other way, you have to do the y as well. So you're going back every single time because it's going up by 5. So every single time you go up, is going to be subtracted by 5. Therefore, from this entry, going back to the previous one, is 0 minus 5. So the y-intercept has to be negative 5. Negative 5. So that's how you get the y-intercept and the slope. Slope is relatively straightforward. Just pick any 2 points. Use the slope formula, you can do it. Y-intercept is being able to look at the pattern of the number itself and go back to 0. You're going to get a y-intercept. So that's where it starts. So moving on. So how about the linear equation itself? So actually I could have done that earlier. You know, the equation can show up, but I didn't do it. Maybe I'll just do it after this example. And this example is a little bit different. I just want you guys to be mindful about this. Pay attention to the arrows this time. Is going up by 5, is going up by 5, going up by 5, going up by 5, going up by 5. So keep that in mind. It is still a constant. So I do have the linear equation that's set up on the x value. So let's look at the y value. This time is a little bit different. It's a little bit different. So it's 100, is 80, so from 100 going down to 80, you actually subtract 20. So from 80 to 60, subtract 20, and so on. You can kind of see that this time is going down by 20 every single time. And so these two numbers that I wrote over there, they still preserve the linear function. I mean, the property of that is the x and the y will be going up or going down by the same rate. So in this scenario, that's what we have. Alright, so to find the slope, you can pick 2 points. You can pick 5, 110, and 80 to do that. So let's just quickly do it. In fact, I want to just type it out because my handwriting is terrible. So I have y value 100 minus 80. So, and then this whole thing we have to divide by 5 minus 10. Okay, so the top is going to be 20. I do have to write it out. 20. And for this bottom bit is -5. So that is going to be -4. So we did get our slope, okay? So the answer for this is -4. It will become very, very useful when we get to the later part of this. So I can erase that. Hopefully I don't need to keep that over there. Okay, y-intercept just like before, because every time it's going back up 5, so if I got one more entry, then I'll get to my 0. So we are going to reverse order. So from 0 going up to 20, 40, 60, 80, 100. And so ideally, when you get to the 0 entry, it's going to be 120. So that's how I would do it. So that's how I figure it out. Now, we are getting to the good part of the equation. So not only you want the equation, because if you have the equation, you can draw it, you can graph it. So if you remember, equation is always equal to, let's remove this, y is equal to mx plus b, where m is the slope and b is the y-intercept. So in this scenario, slope is going to be m, that's going to be b, so just replace them. So my equation itself is going to be y equals to -4x plus 120. Okay, so that will be my equation, and it's very, very useful. Once you have the equation, you can go on to, algebra or decimals, you can draw it. So let's just go back here. So for this example, if I want the equation is going to be y equals to, my slope is 5x plus -5 is basically just -5. So that's where we get this equation, which is extremely useful for a table of value. Okay. That's pretty much it, and I'll spend the rest of today trying to come up with the exercise, but hopefully this video will be embedded in here, and then after watching it you'll be able to do it. If I have to write the whole web page, it's gonna take me days for all those simple ideas. And so if you are watching this and you are not my current student, this year I actually have a website for lots of different things that you can just work on. You can just go there and double check it. It's free. It's for fun. That's all. And this material would be under algebra, I guess. And just do some of those exercises, have some fun, and I'll see you in class. Bye for now.